Okay, what I'd like to talk about, again, my main goal today is going to be to talk about where data comes from, okay? But I did want to talk about one mathematical preliminary, which I haven't mentioned yet, which was at the end of the last lecture. I did want to quickly sum over, which is why do we as data scientists care about logarithms? The other class I teach is algorithms, and in algorithms we teach, we spend a lot of time talking, I give them 4 or 5 reasons why they need to know what logarithms are. In data science, interestingly, there's 4 or 5 reasons you should know about logarithms, but they are different reasons, and that's why I wanted to emphasize this. So what is a logarithm? When we say that y is the log base b of x, that is synonymous as saying b to the y is equal to x, okay? The logarithm is the exponent we need to raise b to get x, okay? And I'm sure every one of you would better have seen that. You probably have internalized it. Why are we going to care about logarithms in data science? And there's a couple of different reasons. One is we're often going, we talked at one point about Bayes' theorem. There is a common way to, or a popular machine learning or classification technique called the naive Bayes approach, where you take the probabilities of each of the features and multiply them. So, you know, you could imagine, you could imagine, that you're trying to, you're trying to tell if something is, a document is spam or not. And you say, well, what's the probability it has the word the in it? What's the probability documents with the are a spam? And probably it has the word dog in it. What's the probability dog is spam? Often you get into a situation where you're multiplying large numbers of probabilities together to get, let's say, the probability of a message. Now, what is a probability? A probability is a number between 0 and 1. It is potentially a small number. What happens when you multiply 2 probabilities together? You get a smaller number. What happens when you multiply 1,000 probabilities together? You get a very, very, very small number. And there are numerical problems. When you start multiplying real numbers that are very close to 0 together, at some point they just blink out into 0. A better way to deal with things is to note that if you have if you take the log of the probabilities, and if you want to multiply a bunch of probabilities, that is in some sense equivalent to taking b to the p, where p is the log, the sum of the logs of the probabilities. Okay, so the sums of the logs of the probabilities will contain essentially the same information as multiplying them, but be a lot more stable. Okay, so whenever you're working with substantial numbers of probabilities, you want to live in log world. Any questions about that? Another reason for dealing with logarithms is when it comes to thinking about ratios. Remember, at one point I was mumbling about the geometric mean. There is this problem that often you've got data that represents a ratio. Okay, like for example, I spent a lot of time working in with a molecular biologists, where they would worry about, they could measure how much more expressed a gene was in one sample than the other, okay? And they typically interpreted this as ratios. They would measure the old gene was red, in sample 1, each gene was colored red. In sample 2, each gene was colored green. They would take the ratio of red to green as to whether there is more of the gene, it's expressed more in one sample than the other. The thing that we noticed was that if we double, if we have the new gene is twice the old gene, that's going to be 200 times the baseline, 200% above baseline. If the new gene was half of what the old one was, that's 50% below the baseline, and that's not symmetric. But what happens if you take the log of ratios? Let's say we take the log base 2 of 2. What do we get? We get 1. What is the log base 2 of 1/2? Somebody out there yell.
1.
1/2. That would be -1, right? Because 2 to the -1 equals 1/2. So what's interesting is if you take the log of ratios, you get the correct thing happening. A doubling is the same as a halving, okay? It's just that the sign is different, okay? So when you're working with data involving ratios, commonly a good thing to do is to take the log of it, because then you can kind of interpret it better. Okay, if you're taking a ratio of 2 equal things, you want to measure displacement. Logarithms are a good way to do that. Any questions? And all kinds of things happen badly if you don't do that. Okay, so here is a project that one of my students once did. They gave me this graph on the left, and they were looking at, if I am correct, if I remember correct, it was 4 different electrical circuits. Okay, they were comparing 24 for each one. They were looking at 24 time periods in a day, every hour, and they took the ratio of how much power was used today versus yesterday. And here is a plot of the ratios. Can anybody see an outlier point here? Okay, one reason you do plots is you look to see where the outliers are. Does everybody kind of get this? This is a ratio of, for each hour of the day, the power usage today over the power usage yesterday. Where is the outlier? Does anybody see an outlier point? Again, we got to be able to read graphs in here. Okay, some people see it, or maybe they say yes, I don't know. Where is the outlier point? Does anyone want to make a guess? Okay.
It's on the top right.
Okay, you think this is the outlier point. That looks reasonable, right? But you're forgetting that these are ratios. Now, suppose we instead plot the log of the ratios. This is the same data on the right, only we plotted the log of the ratios. Now, where are the outlier points? Does anybody see the outlier points here? They're over here and here. Why didn't we see them before? Because when you, because basically the ratio, if you take a ratio, it could be the smallest a ratio can be of 2 positive numbers is 0. The biggest it can be is infinite. Does everybody see that? The ratios of smaller over bigger are all crammed into this space, whereas the other ones are free to grow out there. Okay? So when you take the logs, on the other hand, now you have room for an equal displacement in both directions, and you can start to understand what's going on better. Any questions about that? Do people kind of get the point? Logs of ratios are more meaningful than ratios, okay? Any questions? Okay. Any questions about, I know you guys seem to be rattling on about logs on the chat. Is there anything there that I should be, any question interesting enough to discuss?
I have a question.
Yes.
So for the left-hand plot, that's the x-axis is the magnitude of
The
increase.
x-axis is the magnitude. It's the new versus over old.
Okay, so
This is the log of new over old.
so is it fair in saying that there really is no way to get a negative value with that left-hand side graph?
Okay, so again, on the left-hand side, it was measuring if I had to measure power usage. And in many things in the world, there is no way to get a negative thing. If you're measuring something you see, you don't see -3 elephants. You may see 0 elephants, but you don't see -3, okay? So generally speaking, you know, in a lot of cases, when you're taking ratios, you can't have negative numbers. In fact, if you have negative numbers on ratios are probably a bad act in the first place, because it probably means something different if the negative sign is on top than on the bottom. Okay? Any questions about that?
What if we apply another nonlinear function to the data? Will we get other results?
Okay, so there are other nonlinear things you can hit something with in a log function. And depending upon what you're trying to do, sometimes that may make sense. In fact, the next slide, that might make some sense. But for ratios, I think the log is kind of a natural thing. If you're talking about old versus new, similar things, okay, then I will claim that you know, then I claim that the log is probably the right thing to do. Any questions? The final thing that I want to warm you up about with respect to logarithms is that when you have you know, power law distributed variables, we will talk about power laws later on, okay? But a lot of things in the world are not distributed. There are a lot of things that are distributed by a nice normal bell-shaped curve. There are some things that are distributed by something called a power law, which kind of is a rich gets richer phenomena. And the result is that if you want to make sense of a distribution, okay, it is often better to take the log of the variables to analyze and use as features rather than the you know, the original one. Wealth is something that is power law distributed. Okay, is it a better feature to have the log of the wealth or the wealth in dollars? Okay, you know, wealth has this property, again, because it's a power law distribution. Bill Gates has an infinite, you know, has a huge amount of wealth. If you look at it on a scale of dollars, the ratio of my wealth, if you put my wealth over Bill Gates's wealth, what does that fraction come out to? It comes out to be so close to 0 as to be completely uninteresting, right? What if we put your wealth over Bill Gates' wealth? That comes out to a negative number for many of you. Actually, that's a joke. It's not going to be negative, but you know it's going to be even closer to 0, okay? But what's the difference between my 0 and your 0? It won't look like anything like that. Yet if you take the logs of wealth, again, I'm not a rich guy, but I'm, you know, I've had a job for 30 years, and you know, you know, I'm the same number of logs from Bill Gates in wealth as you are in Bill Gates in wealth, and it's a meaningful thing that there's kind of a, you know, I'm kind of in a middle ground there. Okay, and often when you're dealing with power laws, the log is the more meaningful thing. In fact, fairly often what you get, the case when you get power laws is an example of a skewed distribution. Suppose we were looking at a distribution where, again, this is not what it is. This might be wealth. The x-axis might be your wealth in $100,000 a year, or your income. You know, there's going to be a we probably expect something that's kind of goes up and goes down, but it's not symmetric. Okay, the median income maybe is, let's say, 75. Okay, that might be the median, or the. But if you take a look at this thing, you can't get people too much less than 100 than 0, but you can get people a lot more than the median. If you take a distribution like this and you hit it with a log, suddenly it becomes something that looks more like a Gaussian, beautiful bell-shaped thing. And that's something that we probably want our features to have in general. It's a lot easier. A lot of things, variables, features naturally assume kind of a bell-shaped distribution. If hitting your thing with a log, or since you wanted a difference function, maybe a square root or something like that, makes something more bell-shaped, okay? That's often a better feature than the raw number. Any questions about that? So those are reasons why we're going to care about logarithms in here. Any questions about logs or power laws or money or anything like that?
Oh, and then when we do the final analysis, do we need to normalize it?
So the question is there a time when you need to, suppose, let's say you want to predict how wealthy somebody is. This might be an argument that you're better off predicting, for example, the log of their wealth, okay? Now, suppose, let's say you're trying to figure out and interpret how wealthy somebody is. Once you know the log of their wealth, that may not be, if I told you the log of your wealth was, I don't know, 7.3, that you might not be able to interpret as easily as then taking the exponential, raising, e to that log, okay? And getting an actual number you care about. So often it's easier to predict these things and interpret them in log space. But maybe when you're trying to understand what it means, you may be interested in the, the original value. Any questions? Okay, any questions about that? Okay. Okay, anything else about logarithms or things like that before we talk a little bit about where data comes from? Okay, so that's what I kind of like to talk about now is, if you say, what is it that the glamorous life of a data scientist, okay? Some of you may think that, oh, it's all machine learning, it's all, this kind of stuff. The truth is that in most data scientists in the universe spend their time cleaning up and formatting data sets. Okay, that's one reason why Python's a great language, is it's actually good for this kind of manipulation. Sometimes you run into data scientists who don't spend their time collecting data, and usually they spend their time complaining they don't have data. Okay, and that's, so there's this term called data munging or data wrangling. This is what I consider to be the art of taking a data set and getting it into a format that you can understand and use. And cleaning is one of these important things. We'll talk about that perhaps, I think, next class. But when it comes to data, so I want to talk a little bit today about kind of the data wrangling process a little bit. Some of this is probably obvious to you. First thing is that there are many languages that data science people use at different points in their life. We are talking in here about Python. Python, I think, is probably, the main language in data science. But there's another group of data scientists who would argue with that, probably. Statisticians tend to use a language called R. Have any of you ever used R? Do we have any R programmers here who will admit to it? Okay, what is your experience with R compared to Python? If you want to confess. Okay,
I've thought R was better for most statistical things, but Python has much more developed machine learning libraries.
Right, so R was a language developed by statisticians. So high-powered statistical kinds of things are probably, there's more libraries available for that in R. There's certain visualizations that are available in R that you won't find in in Python. So there's a different world. Certain people love R, certain people prefer Python. You should probably be aware of what R is and play with it. There's a style to using R that some people like and some people don't. But it's interesting to know. It's probably also important to know that as a Python user, you can call R libraries. There are, ways of connecting these things. So it's worth knowing something about R. What other tools should you know about if you're going to be a data scientist? Well, a lot of people think data science is building big data systems. Again, there's a difference sort of between what I would argue big data systems, like the guy who's building the infrastructure at Twitter, versus the guy that's doing kind of the analysis of a small amount of data from Twitter. And for building big data systems, the infrastructure people, those are still Java, C++, things like this. The stuff we're talking about here is for working generally with smaller data sets where performance isn't as much of an issue. Okay, but we would have to recognize that that's a world. There are other more specialized systems like MATLAB and Mathematica that are used for doing certain operations in linear algebra and symbolic math and things like that. And all of these have been trying to get part of the data science pie. I happen to like Mathematica for historical reasons and things like that. But they're different tools. One thing that I don't want to discourage you from is using Excel. Excel is sometimes for actually interactively working with a data set. That's why it exists. Spreadsheets are humble things, but they are still, if you can take a complex data set and get it down to a spreadsheet you can manipulate, that is not a bad thing to do. Any questions? Now, one thing that is critical when you're building a data science project, though, I think, and there's two aspects of building a data science project that I think are kind of important. One is that you use a network, a notebook type of an environment. What is a notebook? Well, you guys should all be using the IPython notebooks, the Jupyter notebooks, maybe some of you using a Google Colab. You are used to looking at a notebook that is something like this. It's kind of a mix of code. It's a mix of commands. What did you type to actually get run? It's a mix of output, which could be graphics and other things. It's a mix of comments and documentation. And typically, when you're building, in real software engineering, your goal is to produce a code base. Typically in data science, what you want to produce is a notebook of analysis, which will be code that you're running, plus the results of your experiments and tweaks and visualizations and tests to see what it looks like, so you can kind of document the entire project. Okay, any questions? The notebook idea, by the way, first came from Mathematica. I mean, there's some history. Actually, Knuth originally came up with this idea of literate programming. Mathematica is a system that made these notebooks popular. And they're kind of a good way to keep track of what you're doing. And one reason that it's really important in data science is it's important that you have kind of a pipeline so that your project can be reproduced, okay? One thing that's going to happen quite often when you're doing a data analysis project is you're going to be taking a data set, like let's say this Russian store data. you're going to do some cleaning on it, and you're going to be tempted to do some manual changes to the data file. Oh, look, there's somebody has all these negative things. I'll change all the negatives to be positive. And then I'll do something else to it. And then you're going to realize, wait a second, negative numbers were for returns. I really wanted that. And it's hard to roll back, okay, to changes that you've made. The notebook idea is kind of the sequence of what are the commands that you actually did to get something. Often at the end of a data science project, you'll have a graph that shows what your results are. And you'll proudly put the graph on a presentation. And someone will say, well, how did you get that number? Okay, or where did it? If you just have a bunch of commands where you didn't keep track of what you actually did, it's amazingly hard to reconstruct what you actually did later on. And that's one of the reasons why these notebook environments are so important. Any questions? I may be beating the obvious, but this level of hygiene is kind of important. Okay? Basically, your notebook has to maintain a data pipeline, all the things that you did to the data set, okay? So that it can be reconstructed, so you can go back and change and improve the first phase, and then repeat the analysis. Too often, people do a first phase, get a thing, edit it by hand, then take that thing and put it through a second thing. And now it's impossible to fix things again. So basically, you should be thinking in terms of pipelines and expect that you're going to have to do your analysis from scratch at the end. So make sure you always maintain that. Any questions? This, I guess, is basic hygiene. It's one of these things, you know that I'm right when I say this, but it's often hard to have the discipline to do that. Any questions? One thing that's important, I think, when people do data science projects is that they take advantage of standard data formats. Historically, people like to write their own data formats, okay? And everybody has their own proprietary format if you're a company, and you know, people like to use arbitrary things. Be aware that there are standard, let's say, tool formats for representing data that are useful because there are tools around that work with them. One thing that's popular are CSV files. This is sort of the representation that is used in a spreadsheet like Excel. All the data can be stored as a .csv file. And this is a good way to transfer tables between programs and matrices, you know, and other things, okay? Now, to be a proper CSV file, you have to worry about things like, what if I have a comma in a text string? The C stands for comma separated files, okay? So it's more than just putting commas between things. In fact, a good practice if you're producing a CSV in a program is try to load it in Excel and see if there's a problem, okay? Or if it works smoothly. If not, you may not really have a CSV. XML is a language for expressing structured but not tabular data. Okay, it's kind of like defining markup languages for things. And again, I've had projects where, you know, we sort of marked up things that were sort of XML-like, but they crashed from time to time. They couldn't use real XML parsers. A real XML thing, you have a specification language, as well as your files. There's ways to check that there's no problems. XML is a good thing. Many of you use JSON, okay? JSON is a, you know, a standard notation typically for shipping data across APIs. That's the way I like to think of it. It stores not only the data values, but also the names of the fields, okay? The net result is that JSON files are often very wordy, but they are self-describing in some way. Any questions? And of course, databases. We're not going to really talk too much about databases in here, but databases are good things for manipulating data. There's a reason why SQL was a popular thing. And if you have a large number of tables, it's often a good thing to pop it in a database. Any questions about that? Any questions about formats or anything like that? Okay. Are there any other formats people use that they like to use, that they're proud of? Okay, these are main, I think, a main class. Okay, what I'd like to now talk about actually are is questions of where data comes from. Okay, so it's you know, the critical thing in any data science project is that you have a data set to work with, and data sets can come with many from many different places. And you know, I just started working today on starting to write up a list of possible course semester projects. One of the things that will separate the good projects from the bad projects is whether they have a meaningful data set on them. Has anybody ever worked on a data set that they are proud of, that came from someplace that was interesting? What kind of data set? Is there anyone here, just to get people alive a little bit? Is there anybody here who's worked on projects where they had a data set? Where did it come from?
Yeah, I worked with a election votes by precinct level from the state governments. I only did it for 3 states, so it was.
So this was, I think, a project. I think I know what project you're talking about. This was about trying to district, what you call it, to district, you know, that when you're decomposing states into congressional districts, there is this problem of gerrymandering. Okay, gerrymandering is kind of an interesting American word for carving up districts so that the votes will come out the way that you want. Let's say you are a Republican and you're in charge of carving up New York into districts. You would like, because you've got to have, there's going to be 40 congressmen in New York. You'd like to make as many of them Republican as you can. One thing is to try to draw a line that all the Democrats are in one place. So they win that one district 100% to 0. And all the rest of the districts are won by your side. Okay? And so the question is, where would you get a data set for a figure to try to look at districts and try to come up with fair, you know, look at a map and come up with fair districts for it. Okay, where would you get data for something like that? Let's just start this as an example. Do people understand what the problem is? You'd like to now try to figure out, how do you draw lines on a map such that every district is balanced between the number of Democrats and Republicans in it. Okay? Where would you want data from? Where would you get it?
Well, you got it from the state governments. Usually they release those sorts of statistics.
So government is probably a good source of this kind of data. Okay? Are there other sources of data there? You probably want maps data. Maps data, because you need to know something about physical location. Okay? There's probably maps data, that there might be a mix of government and private providers. Okay? Trying to think about where data comes from is an interesting thing. Okay. One thing that people should be aware of is that any interesting data set typically comes with something that we would call metadata. What metadata is data about data. Okay? And, you know, that if, you know, you have, like, for example, we have a project right now with my graduate students where we're analyzing a corpus of 100,000 novels that we do natural language processing on novels. Now, the novels are interesting, but making sense of them requires more data than that. And a data set like that probably comes with a table. Who was the author? What was the title? What year was it published? Where did it come from? Okay. Often the metadata, the things that are not the primary thing in a data set, turn out to be kind of the most interesting part of it. One interesting thing about Wikipedia is every time an article is edited, okay, they keep track of what that edit was. And for a lot of projects, the edit history is more interesting than the actual articles themselves, okay? If you want to understand which topics are controversial, if you want to build a social network of all the people, and two people are the same if they've edited the same article, or friends if they're the same article. Lots of interesting things like that. So when you have a data set, it's important to think in terms of what, is there metadata associated with what you want that makes it kind of interesting? Any questions about that? So when I was thinking about this, I came up with a list of like 7 places where data comes from. And I want to talk a little bit about what the specific concerns or issues are with getting data from each of them. Now, one thing I noticed is, again, obviously, if you want to get data, you can always Google it. In fact, there's even a website that Google has, okay, that is designed to make it better to try to find data sets, okay? So this might be something that's interesting to think about or to play around with. But it's important to kind of know where your data is and what you might be able to get or not. Any questions? Okay. The first source of data that I think is important is companies these days have vast amounts of data. Okay, Facebook knows about every, half of the people on the earth. Facebook knows something about. Okay, Google knows more about you than anybody else in the world, because they know all the dark secrets of what queries you have put in and stuff like that. Amazon knows what you buy, okay, and and stuff like that. Blue Cross is an insurance company. They know exactly how healthy you are, and they know what happens to people with certain test results, because they have all the test. They know what test people got, all kinds of things. All of these companies have very, very interesting and exciting data sets and problems to work on with them. What is the downside of data sets that come from companies like these? What is the biggest problem with data sets from companies like Facebook and Google and stuff like that?
Privacy.
Privacy. Well, privacy is a problem for Facebook, because they don't want the data to get, private data to get out. Your problem, the biggest problem, is they won't let you have it, okay? That you don't have access to this data, okay? Usually, for reasons of privacy, or maybe even more important, for proprietary reasons, companies do not, usually release large data sets that are interesting. So a lot of the things in the world data that I would say, oh man, it would be great if we had this, we could play with it. You can't play with it for that reason. Now, of course, if you're an insider in a company, usually you have more access to data than someone on the outside. But even there, it's kind of surprising. Has anybody ever worked for a company? I'm not sure if you guys worked for a company where you didn't have access to all the data that you might have wanted. I don't know if there's anybody who's had that experience.
Yeah, I previously worked for a very large bank, and there was a lot of customer data we were not allowed to have access to.
Okay, so you wanted to, you might have wanted to do some kind of an analysis of let's say, how happy your customers were, or what the account distribution was. But you're saying that internally, some of them, the customers, were hidden. These may have been the criminals that the company worked for, the banked for. It may have been their best customers, okay? There may have been some reason why that was, but it's surprising. I mean, I worked for a while, I had a sabbatical at a industrial research lab a few years ago. And I was astonished how much in the way of siloing there was in this big company of where the, where data was. These were the researchers, they worked for the company, they in principle could help other parts of the company, but there were rules. Nope, this kind of data, you need on a, only certain people can see it and stuff like that. Anyway, that's life. You have to work with it. The good news is that some companies have APIs that they do make public. Like Twitter will have an API and let you get some data from Twitter. You can get maybe, I think they permit people access to something like 1% of all tweets are freely available. There are APIs that will let you get a certain number of specific search queries. Okay, these are good for some projects. We might want more, but that's what we got to live with. Any questions about governments, about industrial sources? Any other experiences people had with them or anything like that? Okay. Another example of a place that has, where data is often available, that is a good thing, are government sources. The government is, the US government, the federal government is now committed to kind of some sort of open data, okay? And, if you go to, there's a website called data.gov, which is kind of a repository of all federal government data sets. And the government keeps records on all kinds of different things. And it's often a, when you need something for a project, often the government might be the place to go. The reasons why they won't let you have data often reduce to issues of privacy. Okay, so you can't expect them to give you data about individual people. But there are, there's a lot of things that are available if you know to look for it. Okay. Any questions about that? One thing about looking for data with the government that is very interesting is something called the Freedom of Information Act. There's a law that basically any person in the United States, maybe it's person, maybe it's citizen, I don't know the details of the law, can request government to give them any data the government has. And the government is kind of obliged to do this if it doesn't violate some kind of a problem. Okay, like privacy. There's some if it's if you say, oh, give me all, I'd like to see all the nuclear missile secrets the United States has. That they would turn down because there is some data that is classified. If you said, give me the name and telephone number of every person in the United States that gets Social Security, that is undoubtedly classified, not classified, that's private. There's a difference there. But for many data sets that if they can't come up with a good reason why you shouldn't see it, they will give it to you. And I remember the first class we had, I talked about the New York City taxi data, about how often every ride, and it keeps track of every single taxi ride that was ever given in New York City. This data was originally obtained by the Freedom of Information Act request. The New York Taxi Authority, Taxi and Limousine Commission, I think it's called. Someone filed them and said, we'd like you, we see you collecting this data on those fares. Can you give it to us? And, people originally, whatever anyone wanted, they would, you would send them a request and they would send you a disk with that data on it. Okay. And eventually they released it more publicly. But it's interesting to know what data, if something you want isn't available, you can ask for it. Okay, any questions about that? And again, different states have different laws about, different states and different cities have laws about data. One question we talked about, someone discussed this issue about getting data about elections. Right, you wanted to know if you wanted to design districts, you want to know where are their registered voters, okay? And what party are they registered for? And in many states, you can go and contact the Electoral Commission and say, I want the list of all registered voters. And many states will give you that data. Okay, some states will say, well, give us $100 and we'll give you that data. But this is data that's actually available for doing analysis that is kind of, it's deemed public data, even though it does have names in it. One project we did as a course project last year that we're still working on was questions of whether whether married couples where the man and woman have different political parties, whether they're more likely to get divorced or not. Okay, this seems like an interesting question. Is it that you and your spouse can vote for different parties, or are you going to kill each other? Okay, and certain states would make public data of all registered voters. Often it includes the address. This is, by the way, a good way to get on mailing lists, is to be a registered voter in these states. Okay, anyway, surprising kinds of data are available if you put your mind to it. Any questions about this?
So I had a question about the Freedom of Information Act.
Yeah.
I'm not sure it's completely relevant here, but say there's a branch of the government in the US that's building a data set on the citizens, and it's not classified, and it's there is no privacy issue. But let's just say that they don't really know the public. They don't really let the public know that they are creating this data set. So if I don't even know it exists, I'm not going to ask for it. So is this something like legal, or is there something like if the government is building a data set?
It's fair that there be things that they're working on that they don't make, they don't think to make public. Okay, I'm working on things. I don't broadcast it to the world, everything I'm doing. You can file, I'm not an expert on this kind of thing, with the exception of once getting the taxi set. I've never filed a FOI application, but there's a form and you write it to an agency and you tell them what you want, and somebody there, is sort of obliged to take it seriously. So, if you think they might have data on such things, okay, you're perfectly fair to go and ask for it. And, again, there's presumably some subtleties of what they are allowed to give and what they're not allowed to give, but this is your right as, an American. Okay, and, any questions about that? Okay, good. So government is a good place to get data from. Another place that is good to get data from is academics, okay? There's certain fields, again, computer science is not one of the fields that generates data particularly. But in certainly in the social sciences, in the economic sciences, in the real sciences, okay, you will have people who devote a large amount of effort to getting, to collecting data. And there was a time when people liked to publish research papers, but they didn't like to make their data sets public because they spent a tremendous amount of time of work on making that data, getting that data. And they want to maybe mine it from multiple papers. But it turns out that in many fields, okay, it's now required that when you submit something for publication, you put all of your primary data in a public database. An example of this that we worked with that I'm familiar with has to do with DNA sequences. Okay, that there is a public database called GenBank that is collects basically every DNA sequence that has ever appeared anywhere in a publication or in a data set that any academic has ever submitted. If you guys want to type a random sequence tonight and submit it to GenBank, you can, okay? But the net result is that people are forced to kind of make their data available, and this provides an incredible resource for everybody else, okay? And the net result is that a lot of biology is done by looking stuff up in a database rather than doing their own experiments now, okay? So again, if you're working on a project where you expect that you're going to need demographic data or medical data or economic data or, whether about, some sort of physical observations like meteorology, okay? If you need this, often there are academics that will do it. How do you find it? Well, one thing that I would typically do is try to find what the right research papers are. There are many sources of research papers. My favorite these days is Google Scholar. So I think that's what is. I think it's like Scholar at google.com. And these are giant databases of the science literature. Based on this, you can look something up. If you see a paper that has a data set, you can ask the guy, can I have your data? Where is your data? Usually they will have a link to it, okay? So I encourage you to track that down. There's often other people have things that are amazingly useful for you. Any questions about that? That's a perfectly fair place to go to get data. One source of data that computer scientists are probably more familiar about doing is kind of web scraping. What is scraping? It's the art of extracting data from a web page. Okay, so that quite often, if you think of what is Google, or at least what was Google at the start, it was something that walked over the web, identified every single web page, extracted the text, put that in an index, and processed it so that you would be able to find what you wanted, okay? When you download when you go to get a web page, make a web page request, you're getting this file, typically written in HTML, that is a mix of commands and text and maybe images and stuff like that. If you can view it on your web browser, that means you have access to the data that was in that file, okay? Sometimes they encrypt data and make it hard. Sometimes they have JavaScript associated with it and a real data file that's underlying it. Bottom line is that there's often ways of getting data from by monitoring websites that is very, very useful, okay? So one of the good things about dealing with Python is that you've got libraries for doing all kinds of things. One famous library in Python is something that is good for helping you write things to extract stuff from a web page. There's something called Beautiful Soup, I believe. Has anybody ever used Beautiful Soup? I see some people nodding. Okay, so so the good thing is that that you can often get data sources. Suppose, let's say you wanted to keep a track, build a data set of what the temperature is in let's say every city in the United States. Can anybody think of a way to do that by web scraping? Might want to get the temperature every hour in the United States. How would you do that?
Google Weather.
Google Weather. So Google Weather would be one thing that you could do. Okay, you could keep hitting Google Weather, and that's going to be an HTML page, and somewhere in there is the representation of what the temperature is at this moment. Okay, if you visit that every hour or every 15 minutes, you will get a time series of that. Okay. What's going to happen if you visit Google every 15 minutes to find out, have a program that goes every few minutes to get the weather by hitting it at Google, the Google weather site? Does anybody
Google
know?
will block the IP address.
They'll block your IP address. Okay, so there is there is an art here of, you know, how often can you visit somebody? Okay, what is it legal to do? What is illegal to do? Okay, and typically a website will have a term of service. Okay, which will tell you something about what you're allowed to do with it. Okay, and many attempts at web scraping are not completely kosher. Okay, again, I encourage you to live within the law. Okay, any questions about that? I also encourage you that before you write a web scraper and before you hammer a website, there are other things that you can do. One is check to see whether or not there is an API available. Does Google Weather have an API that will give you the weather when you actually ask for it politely? It would not shock me if they did. It would not shock me if there were other places where that was available. It's also the case that somebody else may have already written a scraper for it. In Python, if you do a search on GitHub or search through all the Python libraries, you will be surprised. There is probably packages designed to scrape Amazon, probably packages designed to scrape Google or Facebook, okay, or any other, probably Major League Baseball, probably all kinds of sites that people have been interested in before, okay? And it's often better to look than to write your own. Any questions about it? And it's probably better to ask whether or not the data exists without scraping it. We also happen to have the United States happens to have a National Weather Service. And all the data from the National Weather Service is readily downloadable. And they will be delighted for you to take it from them. There was no reason to necessarily hassle Google for that, okay, and scrape things. Okay, so this is something to keep in mind with. Any questions? Any experiences people had with scraping that were particularly memorable, they were proud of? At one point, I built a system for gambling on a sport called Highline. And I wanted to all the time understand, I had to figure out what players were playing the next day and what were the results of yesterday's matches. And to do these, we had to write scrapers, and that was a critical part of that project. Any questions? Associated with this, okay, recognize that, like I said, there are, before you go and scrape things, recognize that scraping a website is often painful to the people that own the website. If you want to access Wikipedia data, Wikipedia is a great data source. It would be a terrible thing to try to crawl Wikipedia. Wikipedia has millions and millions of pages. Crawling the HTML, okay, would be expensive and it bothers people, okay? In fact, Wikipedia makes available a dump of the entire content of Wikipedia, okay? And you can see these dumps from past years, okay? There is no reason to scrape Wikipedia, okay? The right thing to do would be to take their big dump and get that down. A lot of other tempting pages people to scrape, like the movie database, there is some level of API access or bulk downloads that are available. okay? And so before you immediately hammer somebody, okay, go ahead and deal with that. One thing that I will say, this is a practical thing. Because people don't like their website hammered, it's important that you delay, okay? If you're making repeatedly requests of a website, you have to have some kind of a delay loop in there so you don't hit it too often. I typically tell my students if they're going to scrape something, wait a second between every page that you scrape, okay? And that gives you time that you're not going to be interfering with the operations of the place, and they will probably let you be. Any questions about scraping or anything like that? Another source of data that I find that is very interesting these days is what I'm going to call logging data. Okay, that there exists huge, there's this notion of the Internet of Things, and everybody's toaster is going to be on the internet. If you have a toaster that's on the internet, you should be keeping track of every piece of toast that moves in and out of it. Okay, keeping track of the data that is potentially loggable. Okay, it's amazingly useful at certain points in time. So if you have access to a device on the internet, okay, on the web, okay, I encourage you to keep track and log what it's doing. If you have a website, okay, many people have websites. You should know everybody who ever visited your website and what pages they hit. That is a logging data that is, is worth keeping. It's amazing. Of course, storage today is unbelievably cheap. Okay, I go to every once in a while, I go to what's the last hard disk somebody bought? Has anybody who has recently bought a hard disk, a backup disk for anything? Some of you must have such a thing.
I have.
Okay, when did you buy it? When did you buy it last?
Last month.
Last month. How big was your disk?
5 TB.
5 terabytes. And how much did you pay for this thing?
$100.
$100. That's big O of nothing, right? And 5 terabytes. There are 6 billion people in the world, or something like that. Okay. What could you do with 5 terabytes? You could probably store a record for every person in the world on that. Okay. For your private web server, are you going to get billions of requests for it? No. Might you get hundreds of thousands or millions or tens of millions? Keeping track of, if you own a data source, I strongly encourage you to log it and see what happens. Because there's some time when that data, once it gets big enough, it becomes interesting. And log data, it can be very, very interesting. It can just be very, very useful. Some projects that I kind of like with sort of sensor data or log data that I heard was there's a group that actually, in fact, I think I read about this more recently, that's trying to keep track of earthquakes, monitoring all earthquakes all over the world. What are they doing? They're using cell phones. Okay, your cell phone has an accelerometer. The accelerometer is tracking how much motion there is. If you are sitting in your office and there's an earthquake, it's going to jitter, right? If they are trying to collect the amount of jitter on cell phones and where the cell phone is all around the world. Earthquakes happen over a big period place, okay? So if you took your cell phone and you stuck it in your clothes dryer, it's going to get a lot of jittering, okay? But that's probably just you. On the other hand, if there was an earthquake here, thousands of phones would have low jitter. The idea that you can log what's happening on all of these and keep track of them is very interesting to me. I find that thing kind of inspiring. I like the idea that from the taxi data, we can measure how much traffic there is. Okay, it's like you built traffic sensors on every road in New York City. Okay, but all you did was keep track of when people got in and out of taxis. Okay, any questions about it? So if you have access to sensor data, I think that's a wonderful place to get data from. Any questions? Another source of data that is important, okay, is crowdsourcing, okay? One thing that is, has kind of been, it is really kind of a phenomena is how people have voluntarily built amazingly complicated data resources by just volunteering. Wikipedia is, again, everybody's used to Wikipedia. It is unbelievable that Wikipedia works. You have had millions of people contribute knowledge and correct other idiots' bad knowledge, okay, in a way that produces this artifact that is great. If you can find a way to trick everybody else to producing data for you, that's a great thing to do, okay? So crowdsourcing, if you can find a way to ask people, hey, tell me what you think about this, okay? That can be helpful. There are also environments, which I think we'll talk about at the end of the semester, like Amazon Turk, that are very powerful tools for letting you pay people to do things. Amazon Turk is a service where you can basically add an API to call an API that says, pay this person 10 cents to do this piece of work for me, okay? And there's a way of posting jobs, and for a lot of problems, let's say you wanna have people annotate whether a particular sentence is a happy sentence or a sad sentence, okay? You can ask people, okay? You can pay them a penny a sentence, and there are people who will do this for you. So recognize that if you have a modest amount of money, you can get a reasonable amount of data contributed by people under the right conditions. Any questions? Have any of you ever used Amazon Turk for anything? Or some other one of these crowdsourcing platforms? Any stories here? This is a common thing to do in academic research when either to get evaluation data or training data for machine learning things. The final source of data is something that I find computer scientists tend to be very, very, very reluctant to do. And that is to actually work for it yourself, okay? That people are good at scraping somebody else's data off the web. They are good at paying people to do things. What they are often not so good at is actually sitting down and realizing that you can often, by doing a certain amount of manual labor, okay, build a data set that is useful for you to analyze. Sometimes data sets only exist on paper. If you have an old data set, okay, or maybe you have access to a printout, but not the original computed thing, okay? There was a project I once tried to get started with the medical school where they had data about where people had been admitted to, okay? And, but their data only existed on reports, paper printed reports. In order to build a model to predict whether a student was going to get accepted by a school, you needed to have that really data. One thing to note, that if you are capable of typing 1 record a minute, you can get 1,000 records of data in 2 days worth of work, okay? And sometimes I get students who are so afraid, who are afraid to sort of get their own data. They will say, oh, it's all printed. I don't have any, I can't get access to it, okay? Often this is not an unreasonable. There's a question of, can PDF be scraped? if you're if for a well-formed, reasonable PDF file, the answer is yes, you can often scrape it. Okay. If it's a scan of something, maybe the OCR wasn't done on it, and you wouldn't be able to scrape it. Okay. Any questions about that? Okay. It should be clear that there's lots of data sources if you want to play with it. And again, maybe just the last thing I think I'll do today, just quickly. You guys watch these videos. Let's pick a random project and see where you might get data from. Okay, let's say the baby weight. Where would we expect to get data on if we wanted to try to build a model for predicting baby weights? What kind of data sets do we think would keep track of information relevant to every birth?
Would governments do this?
Governments probably keep track of it. Any other groups? I see hospital records. Now, whether the hospitals are making your medical records on the web, do hospitals put your medical records on the web? Probably not. But there are possibly government, public health places, university public health places that might try to produce anonymized data sets. Okay? And again, they might produce a survey of their records. They might produce aggregate statistics. They might be able to do all kinds of things with that. Where might there be data about art auction prices? Okay. Suppose you wanted to try to predict what a painting is going to sell for. Where might there be data about that would help us make predictions about how much paintings would sell for? Okay. Actually, if we look in the back, how much should that painting sell for? Does everybody see the painting up there? Okay. If I told you it was an original Skeena, would that change anybody's opinion? Where would there be data? Where would there be data for predicting painting prices? Any ideas? Okay, auction firms like Sotheby's, yes. Quite often, if they have a public auction, the prices for those things should certainly be announced. So I would expect that there is a certain amount of web scraping that's probable. Some of the data may be made available about past auctions from an auction company like Sotheby's. There are also proprietary data sets. There's probably also data from museums. Museums buy paintings, and they may very well have to make that data public if it's a public museum, what they paid for it. Any questions? Bottom line, I think this is where I'm going to leave you, but I want, hopefully, you can think in terms of when you have projects where you get data from. Okay, if that's all, I'm going to end here, and next class we will talk about data cleaning. Okay, thanks for your attention. I will see you guys then.